Hello and welcome to another video in this series as we learn the basics of Prolog together. Over the last few videos we've been looking at this thing called the cut, and we started learning about it in a fairly gentle way by seeing the effect of the cut, and we saw that it prevents backtracking across the cut. We saw how that could be useful, for example, to improve efficiency of some Prolog programs. If you need a reminder, do go back and have a look at those or have a look at the blog. We're going to conclude a short series of videos on the cut by seeing how it can be used for negation. Let's start by exploring that topic with an example just to ease ourselves into it. So on the screen I've drawn some probably quite bad looking pictures of three people. One is called Mary and James and Sally, and these three people have different preferences for fruit. Mary likes all fruit, so as long as something is a fruit, she will eat it. If it's an apple or an orange, I guess, or maybe a banana, she's happy with that. James, on the other hand, so that's the rule here, Mary likes all fruit. James, on the other hand, likes all fruit, but has one restriction: as long as it's yellow. So I guess bananas, as long as they're yellow, are fine, and maybe if there's sort of a yellow peach perhaps, you might like that, as long as it's yellow. You can even get yellow apples, so maybe that would work too. Let's draw a leaf on those. Sally is also fairly, well, is more open than James. James is quite restrictive here, isn't he? Sally is fairly open, but not as open as Mary. Mary just likes all fruit. Sally likes all fruit except yellow fruit. So as long as it's maybe a red apple or an orange, or maybe even sort of purple plums or grapes, she might like those. So we can encode these preferences in Prolog, and let's have a look at them. This should all be revision because none of this is particularly new for us. So Mary likes all fruit. We can say something like a property called Mary called likes that relates Mary with something, and that this property is true as long as that thing is a fruit. So that's fairly open and liberal. So that's easy enough to do. James likes all fruit as long as it's yellow. So we can copy and paste that rule, obviously changing the name to James because this is about James. So James likes something as long as it's a fruit, but also as long as it's yellow. And in Prolog that's fairly natural, because remember the comma in the body of a rule means and. It's a conjunction. This is a conjunctive rule. Both parts of the rule have to be true. The thing has to be a fruit and the thing has to be yellow. It's not or, it's and the comma does that. So that means in Prolog it's fairly natural to express rules that extend the restrictions, so something and something and something has to be true. Now the last one is interesting, which is the point of this video. Before we dive into it, I should say that in Prolog the way the rules are defined, they're all positive, as in they say something is true, they don't say something is false. So we have maybe a property is true, we write in the positive. We say the property likes is true if. We say, another property might be tasty is true if. So we say something is true, and then we can, in the body, make that increasingly specific with conditions. But what we don't tend to do in Prolog is say something is not true, or write an exception. So that's what we're going to explore today and see how the class can help. So in this one, the last person, Sally, she likes all fruit except, and that's the interesting part, except yellow fruit. So how do we express that in Prolog? Well, it's not an additional positive constraint. It's not saying fruit and it is yellow, or fruit and it is round. So no list of positive restrictions are going to help here. We're going to need the concept of a negation. So we're going to have to say something like, Sally likes X as long as that thing is a fruit, and some kind of negation of the yellow property. This is the bit that's interesting. That's the interesting bit. How do we do that? So up to this point we've not needed to do that, and as I said, naturally the way Prolog rules work, they don't really talk in as negations or exceptions. It's almost always about what is true and what combination of other true things make something else true. It's not natural to say, this is false or this is an exception. So that's something new for us. So I've written the word negation here as a property of yellow. So we haven't defined how this works, and we will come to that. But for now, let's imagine that if yellow X is true, then this turns it into a false, and if this is false, this turns it into true. So true becomes false, and false becomes true. So that's kind of how we expect negation to work. So imagine we have this magic property negation that does that. So that's what we're going to kind of look at and explore today. Before we dive in, let's just practice and warm up our fingers by just testing some of these rules. If you look on the GitHub, that's linked from the blog and from this video, you'll see the example code. We're not going to look at the last bit, we're just going to look at the first bit, and we'll come to the last bit later. So as you can see, in the very familiar way that we've done for so many videos, we've defined some basic facts. So apple is a fruit, orange is a fruit, banana is a fruit. And just to practice, we can say fruit X, what's a fruit? And we can have all the answers, apple, orange, banana. So totally expected. We can ask which fruit is yellow, or which thing is yellow. And we have banana. If we ask whether an apple is yellow, we obviously get false. That's all expected. So we can ask what fruit Mary likes. Mary, just for practice. And we can say F, just to make that a little bit more meaningful. And remember, the capital letter means it's a variable. So running through all the options, Prolog has found apple, orange, banana, all the fruit. If we change that to James, and then what do we expect? All fruit as long as it is yellow. So apple and orange are not yellow. And an apple might be yellow in the real world, but in the closed world assumption, remember, if it's not true in Prolog, then it's not true. So only bananas are yellow. We've not given the option that an apple could be yellow. If we run that, we find only banana satisfies James's taste, and that's again as expected. Now the interesting one is Sally. Just before we dive in, it's worth kind of just visually seeing what those relations or constrictions look like. So Mary likes all fruit, and that's kind of the Venn diagram showing that. Some of them might be yellow, but it doesn't matter as long as it's fruit. James only likes fruit as long as it's yellow. So some things are fruit that aren't yellow. Some things are maybe yellow but not fruit. So it's only fruit and yellow things. So it's a conjunction. This is the interesting case with Sally. She likes all fruit except yellow. So it's anything that falls in this middle section should be excluded. So that's just a kind of an interesting way of looking at this. Some of you may be more familiar with thinking about logic in terms of sets and Venn diagrams. So let's, for the moment, assume that this negation works. And if we run it, we should only get fruit that is not yellow. So apple, that's correct. Next is orange, that's correct. Anything else? Nope, nothing else. So banana, she should not like it. Let's test that. Specifically, it's false. Yep. And apple obviously works because we've just generated the full list. So how does so that obviously works. However, we've defined negation. Now let's have a think about how we would define negation, because nothing in Prolog naturally seems to give us that effect. It's not obvious. So let's have a look at that next. So I've copied over the definition that we've got in the example code, which defines this negation property. And we're just going to talk through it. So you'll hear a phrase in the books, textbooks and courses called negation is failure. And as a set of words, it feels like it doesn't really make a lot of sense. But it's just a phrase that's kind of caught on in the kind of, for those who work with Prolog. Don't let that put you off. So we've got a property here, negation, and we've defined it with two rules. We've got this one and this one. And what we're saying here is that G, negation of this thing G, is true if, remember this is a logical implication in this direction, if this is true and, remember the comma, a cut, which is always true, and fail. That sounds like and looks like a really weird combination of Prolog-y things. It's almost like we pick the worst, most complicated things and put them all into one line, fail and cut. So let's talk through it one by one. So call is a built-in Prolog property which runs G as if it was Prolog code. So G here is a variable, but it could be unified with Prolog code. So this runs as Prolog code, and if the outcome is true, then this succeeds as true. Now you might see some people write just G and not call G, but it's good practice to write it like this, for compatibility reasons primarily. There are some subtle differences in how errors are handled. So if we do it like this, any errors that we might make, the errors that return are always a little bit more helpful. So it's a good habit to get into. It's also clearer to anyone reading what you're trying to do here. You're saying I'm intentionally calling the contents of this variable, the Prolog code that it's unified with, that it contains, as Prolog code. And if it succeeds, then this thing succeeds. Remember, the cut succeeds, so if this succeeds, then Prolog continues from left to right along a rule. It just means that we have a barrier, we don't go backwards. That succeeds, we carry on, and then we fail. Well, that's odd. So if this succeeds, we continue, and then we fail. Now, what's the point of the cut here? Remember, when Prolog fails, it tries to backtrack and see if it can satisfy the head in another way, by backtracking and trying perhaps different unifications, for example, for variables in the search tree. We've seen that before, and again, if you need a revision, do go back and have a look at that. So this is saying if you fail, that's it. Stick to the failure and don't go back. So let's summarize what we've done here. If G is true, then our outcome is actually a fail. That's starting to look like negation, isn't it? If this is true, then this is false, which is kind of what we want. So what's the point of the second rule? Why is it needed? Well, if G fails, we never get past this point. So G fails, we do backtrack, because we never get past that point. So we backtrack, and then Prolog tries the next rule with the negation heading to see if we can satisfy negation G another way. And here we have an underscore which says anything. We could put G here. I guess it might be clearer. I've put it as an underscore just to emphasize and practice what the meaning of the underscore is. It means it's a variable that unifies with anything, and it doesn't really, so it means we don't really care what's inside G. So this time, if G has failed, then we're saying negation of G is now true. Because remember, there's no body here. This is just true because the body is empty. So in this case, if G is false, then the outcome is true, which again looks like negation. Let's summarize that by drawing it differently as almost like a truth table. If G is true and false, let me pick a darker color there. If G is true or false, this is a truth table. If G is true, then what happens here? This succeeds, and then it continues, and then fails. So output or negation G, then it fails, false. If G is false, this fails and we never go past, so we try the next rule, which is always true. This is only ever executed if this one fails. So if G is false, it's true. And if you prefer the ones and zeros, 1, 0, 0, 1, that looks like negation. So we seem to have constructed a property, negation, which simulates, quite effectively it looks like, negation, or turning something into the opposite in terms of success and failure, or true and false. And we've needed to use a cut to do that. It was essential. Couldn't really think of another way of doing it otherwise. So I hope that's clear. You can read on the blog in slower time the explanation of that, and we can see that's what the negation property here is, and that's how it works. So let's try using just negation on its own. So negation, let's just put true in there. What do we expect? False. If we say false or fail, then it's true. So it's flipped the kind of the meaning. What else could we try? Remember, G can be Prolog itself, so we can say yellow banana, and this is true, so the output should be false. Yep. And yellow apple. Now this is interesting. Let's look at yellow apple on its own. So yellow apple on its own, is this true? Yellow apple should be false, because there's nothing in the database that says apple is yellow, so that's false. And then if we put a negation around it, we should have a true coming out of that. Great. So that's cool. could stop there because we appear to have defined something really useful, the negation property. In fact, it's so useful. Lots of Prologues actually have a symbol for it, a kind of built-in, kind of almost like its own property for it. So rather than saying, you might think it's not, so not G or not X, and actually the early Prologues did have not, but more modern Prologues have moved away from not to this combination of symbols, and I'll have to look it up online on Wikipedia or something to remind myself that this was actually just like this, that one there that we see in the rules is meant to be that. I think this is meant to be something like not does not imply, or something like that. I have to look it up, but it's not terribly important. But if you're interested in why those symbols, you can look it up. So this is negation as failure, and it's called as failure because of this method here of if something succeeds, then we force it to fail. So it's this symbol. Not will work probably, but the reason for moving away from the not terminology to this terminology is something we'll talk about next. But let's try this terminology, this new symbol. So let's try that. Yep, that works. And if it was yellow, actually a simpler one is just clearer to see. True. That should be false. Yep. And if it's fail, that's true. The proper reading of this is the word cannot be proven. So let's clear the screen here. So I've written out the first that rule that makes use of negation, and I've just copied and pasted it, and this time I'm using this new built-in property that should be read as cannot be proven. That's the phrase to have in mind when you think about this, and it's slightly different from negation because it's closer to what Prologue is actually doing. It's saying that whatever is in here cannot be proven, which in practical terms means it's false. But that's the way to kind of keep ourselves aligned with how Prologue works. So to read this, we say Sally likes something if that thing is a fruit and it cannot be proven that it's yellow, which is equivalent to except yellow fruit. So that's the reading of that. I don't know if that's got an actual name. Let's just try that. If we change this to the new symbol, let's see if it works for Sally. So likes Sally X. What fruit does she like? And it should give us the same. Yep, apple, orange, but not fruit. But not banana. Great. So that's good. So we've seen how to construct something that works like negation. It's so useful that many Prologues have their own built in. That's great. The last thing we want to look at is just some caution around using negation as failure. So you'll often read in some of the textbooks warnings to say it's called negation by failure, but it's not really logical negation. And we'll just talk a little bit about what that caution is. So we have two queries on the screen, and we are here creating, well, we've created a variable and unified it with fish. Makes sense. And then we are testing whether X is a fruit, and then negating it. So let's talk through. Knowing what we know, well, actually using the database that we have, fruit, apple, orange, banana, nothing about fish. So if it can't be proven that fish is a fruit, then it's not a fruit. So this should fail. So that should be fail because it's not a fruit. And then this should negate it to become true. So we expect the output to be true. The second example has swapped those two parts of the query. Here we have a variable and we're testing to see if it's a fruit and negating it, but later we are unifying it with fish. So logically these two queries are equivalent logically, but we know that in Prolog sometimes that the way Prolog works procedurally, that isn't the case. So what will happen here? So let's see how Prolog would work. So here we might be thinking, well, here's an unbound variable x. X is not bound to any value yet. It's ungrounded, or it's a free variable. What happens to fruit x? Is it true or false? That's the key question. What is it true or is it false? This thing here, just that. Is it true or false? What do we think? Well, it's a grey area, isn't it? Because if this was apple, definitely it would be true. If this was a book, x equals book, then it would be false. But if it's unbound, what happens? Well, it is a grey area, and the design choice that the makers of Prolog went with is that this could be true for some value of x later. So it's definitely not false. It could be true. So we'll treat it as true. It's not false. So that's fine. And in normal Prolog, where we might, write variables in a rule, that's totally fine, because we don't want properties with variables to fail, because the rest of the rule won't get executed. And we've seen that in pretty much all the examples we've written up to this point. So we can see why it should be true. But if it's true, then negating it makes it false. So what's this saying? What's the interpretation if this is false? The interpretation is, if we take a step back and just have a purely logical reading, it's saying the negation, because x is unified with fish, of fruit x is false, which means fruit x is true. So fish was indeed a fruit, which is a big no-no. So you can see how we can accidentally or too easily draw the wrong conclusion. With simple examples like this, you're probably not going to make that false or incorrect conclusion. But with more complicated code, particularly code that you might write over a long time and come back to and extend, or you have different people working on the same code, you can see how misinterpretations can happen. So the way to use this safely, and I wish Prolog would actually have a way of warning you, but it doesn't, is to ensure that whenever you use negation as failure, then any variables are grounded. That's the way to avoid this problem. So that's just the caution there, and that's worth kind of keeping in mind. So negation as failure, it works effectively as negation, as we would want, turns true into false and false into true, which is useful for doing things like exceptions, true except in a certain condition. But it's not purely logical, and this has shown why. And the way to avoid this problem is to make sure that any variables are all grounded. So that's that's probably all we need to say about negation as failure. It's a topic which sometimes is difficult to kind of get our heads into. I certainly found it difficult to understand the first time it was, well, the first several times actually, it was explained in various textbooks. But I hope this explanation has helped. The blog is online if you want to kind of have a look at it. It covers the same content that we did in the video, just in words that are more carefully chosen. I mean, here I'm just talking to you at the top of my head. And it talks through the examples in a little bit more detail. And the code is linked on the GitHub, as you can see, just clicking through, so you can see all the code there. After this video, we've almost completed the course. So we've done the very basics, we've done recursion, we've done the cut. Today was the last video on the cut. In the next few videos, we're going to jump forward a little bit and talk about what some consider quite an advanced topic, and it's not really, because Prolog makes it easy and it's metaprogramming. So I'll look forward to joining you for that one. See you then. Bye.